All right, so if you remember in Algebra 2, and this is going back a ways, solving systems of equations. Like if you have two lines that cross, trying to figure out where they cross at. And we did it with like elimination, we did it with substitution, we did it with graphing, we did it with Kramer's rule. We're going to go through it. We're going to go through it very quickly, just a review of that. So let's say I have two equations. Okay, the truth of the matter is, there are two lines. They could be parallel lines, so they never cross. So there's no solution to this, because they're asking for what points do they have in common. If they're parallel lines, they have no points in common.
Yeah.
If they're the same line, they have all points in common, but most often they are lines that cross, and so they would have one point in common. So they might give you this, and they go, okay, solve this by graphing. Definitely my least favorite way, but with the calculator, it makes it much easier, because if I'm just drawing it out on a piece of paper, my exactness of my graph leaves something to be desired. And if it's like 2.34, I'm not going to get it when I draw it. Okay, the very first thing I have to do for any of the ways to solve it, graphing, elimination, substitution, whatever, especially for graphing, is I need to put it in the right form. If I don't have it in the right form, I can't graph it. So, and I also can't even put it on my calculator. So I'm going to take I should have left room, but I didn't. I'm going to take the negative 3x over, and then I'm going to divide by negative 2. So I have 3 over 2x plus 3. So that's one equation. Okay, then this one, I'm just going to take the x over. So that's my other equation. Not to mention my ink is running out. Okay, so if I go to graph these two things. Okay, remember I'm going to go up 3. And that's going to be my y-intercept. Then I'll go up 1, 2, 3, and over to the right, 1, 2. Okay, so there's that line. Okay, then I'm going to come over here and I'm going to graph that line. Then I'm going to go down 1 and over to the right 1. Okay, that's my point of intersection. Now, obviously on the board, I could make a guess. I'm guessing like negative 2, 0, something like that. But it's not going to be extremely accurate.
Right.
So now on a piece of graph paper, yeah, maybe.
Yeah.
So what I'm going to do is I'm going to put both of those into my calculator, if you remember doing that, under y equals. And once I get them both put in, then I'm going to graph them. And then I'm going to go second calculate and go to intersect, which is 5, hit enter, and keep hitting enter until I get intersection at the bottom. Oh, I did a pretty good guess. Negative 2, 0 is what they tell me. See if you can get to that spot. You got it?
Maybe?
Okay.
Oh.
Yeah,
Oh,
you
there
gotta
it
wait
is.
for it to graph. Okay, now,
Okay.
and after guess, it should give you a
Okay.
negative 2, 0. Okay, so that is the point that works in both of these. I can plug in the point negative 2, 0, and that's gonna make that true, and that's gonna make that true. Because that is the one point that they have in common, the negative 2, 0. So this means that this is a consistent, I don't know if you remember these, but consistent, independent system of equations. If it's parallel lines, it's inconsistent.
Right.
If they're not parallel, then I know they're consistent, and then it's dependent if it graphs the same line,
Okay.
and independent if it crosses in one spot. Okay, you
Okay.
had that before, that's
Yeah.
just a review, if you will. If it is inconsistent, it means there's no answer. Okay, it means they never cross. All right, so the first way is by graphing. I would use if they say by graphing, use a combination of getting it on just a simple graph, but then use your calculator to double check it.
Okay. Okay. So
Okay.
you both.
All right. Then we did something called, we said solve it algebraically. Okay, and under algebraically we had elimination and we had substitution. It really depends on your equation as to which one's easier. This one is really set up for elimination. Okay, elimination means I'm going to eliminate out either the x or y. And I'm going to, and you'll remember this once we start it, I'm going to multiply this one by 2 so that it lines up the y's, but then it has opposite coefficients.
Okay.
Okay, I'm going to bring this one over, so I have 3x minus 2y equals -6. So let me know when that thing clicks, because I've got set the timer. 2x plus 2y equals -4. Okay, I had to multiply everything by the 2. The reason why I did that is because that will now eliminate out the y. Remember, the goal is to eliminate out the y or the x so I can solve for the other one. Okay, so when I add those together, I get 5x equals -10. When I divide, I'm going to get x as a -2, which is what I got before when I did graphing. Okay, so then to find the y, I just plug it back into one of these. The bottom one's probably the easiest one to plug it into, but it doesn't matter. You can plug it in here, here, or here. Or here if you've changed that.
Okay.
Okay? So I have -2 plus y equals -2. So I'm going to add a +2. So I'm going to get y is equal to 0, which is what I got. Okay?
Yeah.
You know, that I got the same thing when I did it by graphing.
Okay.
Okay, so that's elimination. Substitution, we did some substitution within elimination. Substitution, this one's really not set up perfect for substitution, some of them are. But this one, what you have to do is you have to solve for either the x or the y first. Now, I wouldn't want to do it up here because that will give me fractions, because I've got a number besides 1 in front of the x and the y.
Okay.
But I can do it down here. It doesn't matter which one I solve for. Let's say I'm going to solve for the x. So I have -2 minus y. Then what I do is I take this is what I call my key, and I put it back up here for the x. Okay, that's what x is equal to. So then I go, well, rather than writing x, I'm going to put what x is equal to. X is equal to -2 minus y minus 2y equals -6. I'm going to distribute -6, -3y, -2y equals -6. You with me so far?
Yeah.
Okay, so here I've got a -5y, and here I've got 0, because I'm going to add the 6. So when I divide, I'm going to get y is equal to 0, which is what I had. Then I just take it and plug it back into the key. So I have -2 minus 0. So I find that x equals -2. Same answer, whether I did it by graphing, or whether I did it by elimination, or whether I did it by substitution.
Right.
Okay. Now, when we did this in Algebra 2, we also used Kramer's rule. That was another thing we did.
Yeah.
You'll never remember Kramer's rule, so we're not going to go back over it. Okay, okay? That's not gonna be one that you pull out of your head.
Yeah.
So we'd rather stick to the ones that we know are going to serve us well in the future.
I was so determined to memorize that because you said we wouldn't remember it, but
But you don't remember it, do
Yeah.
you? I mean, that's simply put, you just don't. Okay, I want you to try one, okay?
Okay.
Now, I'm not gonna tell you how you have to do it, okay? The
Okay.
book might, I'm looking to see, yeah, it might say, it just says solve algebraically, is all
Okay.
it says. And then this one says solve by graphing. So obviously you have to end up being able to do both.
Okay.
So this one I'm gonna let you choose, and then we'll do one a way that you didn't choose, okay?
You always choose elimination when I.
That's me too.
Yeah.
That's my go-to spot. I probably on this one would probably multiply through to get rid of my decimal first,
Oh.
but you don't have to. I tend to try and make life a little bit easier on myself.
Okay, so those go together, right?
Those go together.
Okay.
Those are your
It's not
two.
different.
Those are your two equations. So
Okay.
what you're trying to find out is whether these cross, and if they cross, where they cross.
Okay.
This is probably some of my favorite stuff in
Yeah.
I mean, this whole section, this section and the next section. I'm gonna do it up here while are you doing it by elimination?
I was, but I don't know if that's.
Yeah, I would.
You would? Okay.
Yeah, I would. I'm gonna rewrite it though. I'm gonna multiply through to get rid of my decimal, cause I just don't like to work with the decimals.
Okay.
Oops.
yeah, you just chose to do.
I
Which other one?
I chose to do elimination, and then I
Right.
chose to plug it back into, I guess I used this
This
one.
first one,
But
okay,
you can
yeah.
use this,
Right.
or this. It really does not matter what you
Okay.
plug it back into,
Yeah.
okay, because it's gonna work. Does that make
Okay.
sense?
Mhm.
You good with that?
Sure.
Now, you can make some careless mistakes that
Right.
way. All right, okay, this one I'm gonna tell you, you've got to solve by substitution,
Okay.
okay?
I think I got that one.
I think elimination you probably have.
Yeah.
This one's actually an easier one. But don't expect to get whole answers on this one,
Okay.
okay? So don't think, oh, I did something wrong
Yeah.
because they're not whole. Just leave them as fractions, if you will. Okay, use substitution on that one.
Okay.
This is still recording.
I didn't hear it correctly. Wait
No.
a second. 2 plus.
Well, I think I did something wrong. Hold on. Oh, I did it right here.
3. Okay.
I changed my 2 to a 3 for some odd reason, which is gonna make all of this off. All right, so your y is 4s, and then when I plug it back in, I don't know which one you plugged it back into, but, well, it would make more sense to plug it into that one. So basically, x is 2 and 4/5, or that would be 14 over 5.
Okay.
Okay? All right, then I'm gonna have you do 1 by graphing,
Okay.
okay? Now, it's already set up nice, so like I said, kind of do a combination. You can do a sketch graph, and then use your calculator to verify your point, because I don't think with our sketch graph, we're really gonna be real accurate.
Right.
But I do wanna make sure that you can graph it.
Oh, and those are already set up.
Yeah.
Okay.